consider this reaction. We have Mg plus Cl2 producing MgCl2. This is already balanced, so the coefficients here is 1 to 1 to 1. The ratio here is for every 1 Mg, we need 1 Cl2, and that can produce 1 MgCl2. If 48.62 grams of Mg will react with 70.90 grams of Cl2, determine the limiting and excess reagent, the theoretical yield, amount of excess reagent left at the end of the reaction, and percent yield if 91.74 grams of MgCl2 is actually obtained from the reaction. Let's start with the limiting and excess reagent. The word reagent is the other term for the word reactant. So here we have two reactants. Let's identify which of the following reactant will be the limiting and which one will have an excess. So here we have the amount of the reactant is 48.62 grams of Mg, and for Cl2 that's 70.90 grams of Cl2. So the first thing is to actually calculate how many grams of MgCl2 can be produced from this amount of the two reactants, and the one that can produce less amount of product, that will be the limiting reactant. So first we'll do a mass to mass calculation. Okay, mass to mass calculation. This will be from the mass of the reactants to the mass of the product that can be produced from the reaction. So here, let's start with 48.62 grams of Mg. 48.62 grams of Mg. So first, let's convert this one to the mole of Mg. Mole of Mg. 1 mole of Mg. 1 mole of Mg is 24.31. So the molar mass of Mg is 24.31 grams. And then from mole of Mg, let's determine how many moles of MgCl2. Mg to mole of MgCl2. This is the molar ratio, so just look on the numbers on the and all numbers here is 1 1, so that's 1 mole to 1 mole of Mg. Next, we'll convert the mole of MgCl2 to its mass. So what's the mass of MgCl2? Let's determine the molar mass of MgCl2. That's MgCl. We have 1 Mg, then 2 chlorine. So for Mg, that's 24.31. Then for chlorine, we have 35.45. 24.31, and then 35.45 times 2. Again, 35.45 times 2. That's 70.9. Then add this one. Okay, we add that 70.9 plus 24.31. That's equal to 95.21. So the molar mass of MgCl2, that's 95.21. 95.21. What's left is MgCl2. And then let's do the math here. That is 48.62. 48.62 times 1 times 1 times 95.21. The answer is 4629. Divide it by 24.31 times 1 times 1. That's obviously 24.31. So divide this one by 24.31. And the answer is 190.42. So 190.42. We have 4 sig figs here. Let's round this one to 4 significant figures. 190.4. So 190.4. 48.4 grams of MgCl2. So we have again 48.62 grams of magnesium can potentially produce 190.4 grams of MgCl2. So this is the expected amount of the product formed if all of this will be used in the reaction. But let's see the other reactant. The other reactant here is the 70.90 grams of Cl2. 70.90 grams of Cl2. We'll do the same mass to mass calculation from the mass of chlorine to the mass of the product, which is MgCl2. So here that's grams of Cl2, then mole of Cl2. 1 mole of Cl2 is, okay, for Cl2 that is 2 chlorines, right? So that's 35.45, 35.45 times 2, that's equal to 70.9. So the molar mass of Cl2 is 70.9. And then from mole of Cl2, let's determine the mole of the product, MgCl2. Then the numbers here, that's 1 to 1. And then from the mole of MgCl2, convert this one to its grams, MgCl2. Now, the molar mass of MgCl2 is 95.21. We have solved this one earlier, 95.21. Cancel gram of Cl, mole of Cl, 2, MgCl2 cancel. What's left is the gram of MgCl2. Now, if you do the math here, you multiply, that is 70.90 times 95.21, 95.21. Then let's divide it by 70.9 times 1 times 1, that's 70.9. 70.9, the answer is 95.21. So the answer is 95.21 grams of MgCl2. Again, we have two ingredients. So here the Mg can produce 190.4 grams of MgCl2, but the Cl2 can only produce 95.21 grams of MgCl2. Therefore, this one is the limiting reactant. So for this one, again, this can produce lesser amount of product. This can only produce 95.21. Therefore, Cl2 will be the limiting reagent or the limiting reactant. Again, limiting reactant, and then the Mg on this case, it will be the excess reactant. So meaning we will have an excess of Mg on this reaction. So again, limiting is the Cl2 while the excess is the magnesium on this reaction. Now, what's the expected amount of the product from this reaction? It will depend on the amount of the limiting reactant. And we have solved that one already. So this reactant can only produce 95.21 grams of MgCl2. So this will be the theoretical yield. This will be the expected amount of product that can be produced from this reaction. So again, here the expected amount or the theoretical yield is 95.21 grams of MgCl2. Okay, let's continue with the amount of excess reagent left at the end of the reaction. So the amount of excess reagent actually depends on the limiting reagent. So let's go back to the limiting reagent. Again, the limiting reagent here is the Cl2. That's 70.90 grams of Cl2. Let's determine how many amount or grams of the excess reactant will actually react with this amount of the limiting reactant. So that's 70.90 grams of Cl2. We'll convert this one first to the number of moles. So 1 mole of Cl2, the molar mass of Cl2 is 70.9, 70, okay, that's 70.9 grams. After this, from mole of Cl2 to the mole of Mg. So that's the mole of Mg. The ratio is 1 to 1. And then from the mole of Mg2, it's grams of Mg. Now 1 mole of Mg is how many grams? That's equal to 24.31. 24.31. Okay, 24.31. So cancel grams, mole, Mg. What's left is the grams of Mg. Then let's do the math here. That is 70.90, 70.9 times 1 times 1 times 24.31. Then the answer divide by, okay, that's 70.9. 70.9 divided by 70.9. The answer is 24.31. Okay, 24.31 grams of magnesium. So this shows that uh, only 24.31 grams of Mg will react completely with 70.90 grams of Cl2. But we have 48.62 grams of magnesium. Again, we have 48.62 grams of magnesium. But from this mass, only 24.31 can react with the limiting reactant, which is so the here we only have 24.31 grams of Mg reacting, so there's an excess. So just subtract this one, 48.62. Okay, 48.62 divided by 24.31. The answer is, sorry, it must be minus rather. 48.62 minus, okay, minus 24.31. The answer is 24.31. 24.31 grams of Mg. So this will be the excess amount of Mg left at the end of the reaction. Next, let's determine the percent yield if 91.74 grams of MgCl2 is actually obtained. So again, we are expecting to have 95.21 grams of MgCl2, but there are different factors that can really affect our reaction. So this can be, our actual value can be smaller than this one. And again, on this problem, it states that what if we can only produce 91.74 grams of MgCl2? What's the percent yield? The percent yield is the percent between the actual yield over the theoretical yield. So again, the theoretical yield, that's 95.21. So 95.21 grams. But then again, we only have 91.74 produced from the reaction. Then we'll multiply this one by 100 to change it to percent. So we'll divide it first, 91.74. 91.74 divided by 95.21 times 100. So the percent here is 96.36. 96.36. 96.36%. This is the percent yield for the reaction.